Hello my students, how are you? Today's lesson is starting from electronic configuration. As we have discussed before about electronic configuration. Electronic configuration is a systematic distribution or systematic arrangement of electrons in each energy level. So, what are the first 20 elements and how can we draw their electronic configuration structure? That means each and individual elements can have their own atomic number and mass number. So by using the atomic number of the elements, we can draw their electronic configuration to reduce the different properties of elements. So let me show you how can you draw the electronic configurations of the first 20 elements. Here it is, there is a symbol of the elements here, and how can we draw their electronic configuration? The first element is hydrogen, its atomic number is 1. The second one is helium. Helium belongs in 2. That means here lithium is 3, beryllium 4, boron 5, carbon 6, nitrogen 7, oxygen 8, fluorine 9, sodium 10. Sodium. There is also another element between fluorine and this sodium. Sodium is 11, magnesium is 12, aluminum is 13, silicon is 14, phosphorus is 15, sulfur is 16, chlorine is 17, argon 18, potassium is 19, and here it is calcium is 20. These are the first 20 elements, except the element is found between this one and this one. That means fluorine and sodium. There is another element that is found between the two. This is known as the first 20 elements. And how can we draw their electronic configurations using their atomic number? The number that I give here is that it is known as atomic number. So to draw the electronic configurations of elements, we have to use the atomic number of the elements, which is given by Henry Moseley to draw the electronic configurations of elements. Henry Moseley is stated that when elements are arranged in their increasing atomic number, they have their own periodicity or periodic functions. That means each and individual element can have its own periods and group when we arrange elements according to their atomic number. So, using the suggestions of the idea of Henry Moseley, Dmitry Mendeleev, which is a Russian chemist who is known as father of modern periodic table, he listed the modern periodic table by using the atomic number of elements, which is suggested or given by Henry Moseley. So, using the atomic number to draw the electron configurations of hydrogen, the atomic number of hydrogen is 1, means the electron number of hydrogen is also 1. That means this K shell can hold 1. This is the electronic configurations of hydrogen, because hydrogen can have only one atomic number. That means it have only one electrons. Helium is 2, so K shell can hold only these 2. Lithium is 3, 2 electrons is here, and 1 electron becomes here in L shell. Because as I have discussed before, K shell, L shell, N shell, N shell, or P and Q shell can hold the maximum number of electrons. So according to their maximum number of electrons, we must write the number of electrons by using their maximum number of electrons accordingly. Then beryllium have here 4 and 2, 2. Boron 2, 3. Carbon 6 electrons. So N shell can hold maximum of 2 electrons. The remaining one is 4 electrons. So we are going to write 4 electrons here because N shell can hold a maximum of 8 electrons. N shell 2 and the remaining one is 5. O shell and also this one and 6. Fluorine 9, 2, and the remaining one is 7. Sodium 2 here and 8. The remaining one is what? 1 electron, which is here it is M shell, because the K shell and N shell can hold the maximum number of 2 and 8. Then the remaining 1 electron is proceed to the next shell, M shell. Argon, magnesium 2, 8, 2. Argon, aluminum 2, 8, 3. Silicon 2, 8, 4. Okay? Phosphorus 2, 8, 5. Sulfur 2, 8, 6. Chlorine 2, 8, 7. Argon 2, 8, 8. Potassium 2, 8, and 8. The remaining one electron is proceeding to the initial sphere. Calcium 2, 8, 8. The remaining 2 electrons proceed to the fourth shell. This is the electronic configurations of the first 20 elements. Then, by using the electronic configurations of the first 20 elements, how can we give the period, group, valence, and valence number, and also the rest properties, type of charge. These properties are deduced by using the electronic configurations of elements. So, for example, what is the period, group, valence number, and type of charge of this chlorine, potassium, calcium, sulfur, also phosphorus, and nitrogen? As an example, let me do and let me show you how can you obtain the period, group, valence number, and type of charge of this element. For example, the period of nitrogen. Period means number of shell. Period means also number of shell. That means nitrogen, how many shell do we have on nitrogen? Here 7 to 5. We have what? 2 shells. So, if the number of shells of nitrogen, when we are going to draw the electronic configuration of the element, it tells us the period that the elements belong. So, nitrogen belongs in period 2 because its number of shells becomes what? 2. What about the group? Group means valence number. Group equals to valence number. So, valence number means the outermost number of electrons when we are going to drawing its electronic configuration. For this reason, nitrogen have 5 valence number. That means the outermost number of electrons of nitrogen is 5, means nitrogen is found in group 5 is the point. The other one is phosphorus. Phosphorus also can have its own electronic configuration. That means it is 15 to 85. This is the electronic configuration of phosphorus. And then phosphorus have the third shell, or it is found in period 3. And what about the group of phosphorus? The outermost shell number of electrons of phosphorus is ends in 5. That means phosphorus is found in group 5. So, in group 5, it's the same as that of nitrogen. That means the group of nitrogen and phosphorus is the same. Chlorine is also can have its own number of shell. Chlorine is 17, that means 287. So it is on the second shell which is found in period 3. And the outermost number of electrons of chlorine is 7, means it is found in group 7. So using these examples, you can write the period, group, valence number, and type of charge of each element. What about the valence of these elements? The valence of nitrogen. Nitrogen found in group 2 and found in period 2 and group 5. When the outermost number of electrons of an element ends in 5, 6, and 7, its valence becomes cut and anion or negatively charged particles. That means it gains electrons to form or to combine to produce compounds with another element. And the outermost number of electrons of nitrogen and phosphorus is 5, means therefore valence becomes -3. Because to fulfill the octet rule or to become stable, to react with any other element to produce compounds, they leave these 3 electrons for another element. So this is what called valence, because as we have discussed before. Balance means the combining capacity or the combining power of one element with another element to form or to produce compounds. Whereas chlorine, the outermost element of electrons of chlorine 7 is chlorine needs one electron to become stable, so its balance becomes -1. This is the point. So using this here, trying to write the electronic configurations of any other elements and deduce these properties of elements. That is all about for today's. If you have any comment or suggestion, please try to write your comment, your questions, your suggestions on comment, and please don't forget share. Please share.